let us try to solve this system of equations using elementary row operations and Gaussian elimination. Okay, perfect. So first, we have 4 equations in 4 variables. Again, we can go back to elementary algebra and try to solve this. But since we are in linear algebra, we want to apply some new technique, some new method. So first, let us form the augmented matrix. In our augmented matrix, we have the very first column for the coefficient of x1. This is 0, x1 plus x2, so 0, 1, 2, and 1. The second column is the coefficient of x2, which is 1, 2, 4, and negative 4. The third column, coefficient of x of 3, which are 1, negative 1, 1, and negative 7. And the fourth column are the coefficient of x of 4, negative 2. This guy doesn't have x4, so this is a 0, negative 3, negative 1, and the very last column are the constants, negative 3, 2, negative 2, and negative 19. Remember that we try to have a matrix of this form. 1 with some elements, 0, 1 with some elements, 0, 0, 1 with some elements, 0, 0, 0, and 1. So this is our goal. We want to convert this matrix to this form using the operation that we learned before. What we see here, the very first element, leading coefficient is not 1, it is 0. It must be 1. So what are we going to do? We're going to interchange 2 rows. We're going to interchange R1 and R2. Interchange R1 and R2. This matrix becomes 1, 2, negative 1, 0, and 2. And the second row is 0, 1, 1, negative 2, and negative 3. Let's copy down the rest of the rows. 2, 4, 1, negative 3, negative 2, and 1, negative 4, negative 7, negative 1, and negative 19. Very well. So compare the matrix with the matrix that we need to have. So A, B, C, D, to avoid any confusion. 1 and 1. It has 0 on this location, but it doesn't have 0 for the rest of these. What are we going to do? We're going to multiply the very first row by negative 2 and add it to the third row. We're going to multiply the first row by negative 1 and add it to the fourth row. So negative 2 times R1 plus R3 and replaced R3. So negative 2 times R1, it gives us negative 2, negative 4, 2, 0, and negative 4, plus the third row, which is 2, 4, 1, negative 3, and negative 2, which is 0, 0, 3, negative 3, and negative 6. So this matrix becomes, copy down the very first row, 1, 2, negative 1, 0, and 2, 0, 1, 1, negative 2, negative 3. Your new third row is 0, 0, 3, negative 3, and negative 6. I'm not going to copy down the fourth row right now. I'm going to make that adjustment that I need and rewrite this. Negative R1 plus R4 and replace for R4. Let's move this a little bit up. Negative times R1. Negative 1, negative 2, 1, 0, and negative 2 plus R4, which is 1, negative 4, negative 7, negative 1, and negative 19. Hey, this guy becomes 0, negative 6, negative 6, negative 1, and negative 21. Perfect. So my fourth row is 0, negative 6, negative 6, negative 1, negative 21. Very good. So far everything looks similar. 1 and 1, and all elements below 1 are 0. So far we're good with the first column. We need to check the second column. The second column has 1, and then below 1, you have 0 and 0. So on the main diagonal, you have 1, but here you have a 0. Unfortunately, we have a -6 here. So we're going to make some adjustments here. We're going to multiply the second row by 6 and add it to the fourth row. 6 times R2 plus R4 and replace for R4. So here I have 1, 2, -1, 0, and 2, 0, 1, 1, -2, -3, 0, 0, 3, -3, -6. And then if I multiply the second row by 6, I get 0, 6, 6, -12, and -18, and add it to the last row, which is 0, 6, -6, -6, -1, and -21. Okay, this new element 0, 0, 0, -13, and here you have -39, 0 and 0, another 0, -13, -39. Very good. So let us take a look at the elements on the second column. Whatever is on top of 1, I don't care, whatever that number is. But on the main diagonal, I have 1, and then 2 elements below 1 must be 0. As you can see, I have a 1, and elements below 1 are 0. So I am allowed to go to the third column. My third column, the element on the main diagonal is 3, which must be 1. Take a look at your form. It must be 1. So let's put this. We're good with the second column. We're moving to the third column. It must be 1 with 0 below 1. Okay, unfortunately, I don't have any 1 here, but I can divide the third row by 1 by 3 or multiply it by a third. So let us do that. A third times R3. This guy becomes the very first 2, -1, 0 and 2, and 0, 1, 1, -2, -3. So far, so good. 0, so a third. 0 times a third, third. 0 times a third, third. A third times 3 is 1. -3 times a third, -1. And here I have -2. Let's copy down the last column, 0, 0, 0, -13, and -39. Very good. I'm good with the third column as well. The last column is left, must have 1 on the last element of the main diagonal. Unfortunately, I have -13. So the easiest thing is to multiply R4 by -1 over 13 times R4. So my matrix becomes, just move this here, 1, 2, -1, 0, and 2, 0, 1, 1, -2, -3, 0, 0, 1, -1, and -2, 0, 0, 0, 1, and here I have 3. Very good. So your matrix is reduced. The augmented matrix for the original system of equations is now written in nicer, simpler form. Nicer and simpler. What do I mean by that? It means that I can write a system of equation that is equivalent to the original one. I have x1 plus 2x2 minus x3 equals to 2. From the second row, I have x2 plus x3 minus 2x4 is -3. From the third row, I have x3 minus x4 equals -2. And from the last row, I have x sub 4 equals to 3. So I easily have the solution for x sub 4. I can substitute that in the equation, including x3 and x4, and solve for x3. x3 becomes 1. Now I can use x sub 4 and x sub 3 to solve for x2 and x1. My x2 becomes 2, and my x1 becomes negative 1. So the solution for the original system is 1, negative 1, 2, 1, and 3. Negative 1, 2, 1, and 3. The intersection between these four equations has one solution, which is negative 1, the x, y, z, and the last parameter are written this way.